And I must say that yes, of course, we have the we have this default access access to our members, and the default we will discuss later on. I don't want to go because it just adds to another series of experiments with in terms of different syntax. I'm not going to discuss default level of access at this point. It's very similar to private, but we'll talk about this later on. All right, so annotations. Here's another example. I will tell you that example with shapes is pretty much the classical example where you have an arrangement of some sort of like drawable primitives, and you want to organize those drawable primitives. You want to make this set of drawable primitives extensible. You also want extensible from the programming language standpoint, that you can easily add new shapes to the hierarchy of shapes. And then also, of course, you need to have a standard way of storing a collection of those primitives. So this is a classic example of inheritance. But this is yet another example where we can consider that if we want to design a software which is called like a product database, which the product database could be used in different areas, for instance, in production of DVDs, or in a bookstore, or in a video or computer game shop, or in a warehouse setting, right? We could design a subsystem, a software which deals with the needs of those particular business domains, if you will. So, one of the simple approaches to designing a system would be to say that in this setting, if we have to think about a design for this product database application, we could have we could think about useful classes that we might have in this application. For example, a product, right? And a product could potentially use code description and price, right? That's reasonable. So we could say that any product, including books and DVDs and other things, very useful piece to them would be the description, which every single one of them would have some sort of internal code, and also the price. Well, sometimes the price could be taken out because it could be a market price, which is marked differently each day, but it's at least in this first take on this subsystem, we can say, okay, maybe price is also a reasonable thing to have. And I use this table arrangement to say, okay, I can have classes such as product, book, DVD, software download, which could be, if this is a web accessible interface, then someone could download a piece of software instead of buying a CD and just simply store an image of what they just downloaded, and that's the type of distribution. And of course, a video game or computer game is another type of product. But certain classes, such as book, for instance, could benefit from additional attributes. For example, we could specify the weight, the author of the book, and the publisher, right? So I'm not saying what type of attributes author and publishers are. Potentially, they could be, author and publisher could be other classes in the system, right? And so author and publisher could be references to those other classes in the system. However, the weight, why we might want to have a weight. The weight of DVD is sort of like predetermined, but weight of each book is different, and so we want to be able to print shipping labels beforehand before we do the packaging, and we would probably want to already know what the weight is. So typically, the publishers for the books specify precisely what the weight of the product is, and therefore we can store this in our database so that we can print shipping labels before we done with packaging of those specific items, right? And this is extremely useful when you have a customer who is buying a combination of different products, and you can clearly, instead of shipping everything in separate boxes, you can just decide what box you want, and the weights are already computed. But other products like DVD and other products may also benefit from the weight. However, of course, software download does not require a weight. So you have those design decisions where you say, certain classes should have certain attributes, and certain classes should not have certain attributes, right? So, for instance, if this was a published book, then maybe we don't need a version, but the software will have a version almost always available to it. And of course, the release date is also applicable to software. But notice how the game here is empty, because it simply inherits all of these attributes from these other classes. So it's very possible that if I wanted to draw a diagram, and I will use this particular example here, right? If I resize this, and if I wanted to create a diagram of this particular subsystem, of course I don't have much space here, but if this was a product right here, right, my product class, this was a book, then of course I would most likely derive this way from derive it this way. So this would be my book class, this would be my product class in my design, right? Then I could have a DVD class in addition to these two, and of course the same way I can derive. I'm not using any fancy UML tools today, so this is just a quick drawing, and this is my DVD class, right? And so and likewise I can have software download and the game, and this way I can just introduce additional hierarchy and design my software as set of classes that are extending from a product, right? But before I decide on a specific hierarchy, oftentimes it's useful to just take a look at potential data attributes and useful classes. Sometimes those attribute class dependency tables may be very useful in terms of how you can plan for a specific hierarchy of classes when you already getting much closer to your design. So just keep that in mind, and I just wanted to show you this in this particular handout. All right, so we already did see the syntax for creating subclasses, and we did see the extends keyword, which we use between the base shape and the specific shape, such as circle or rectangle. And of course, the extends keyword is what we use in software. So in particular with Java. With Java, we have extends keyword, and that provides us a way to specify relationship of the superclass and the subclass. So we already saw the superclass constructor call. We said in our example that it's very useful if a rectangle in its constructor was able to call the superclass constructor, and this is how it's done. Then we also realized that if we wanted to implement custom conversion of our class to a string, we can still define in upper levels of hierarchy, we can redefine to string, and if we wanted to make a call into the superclass methods, what we can do is that we can use, once again, the superclass keyword and say, superclass, give us your version of the toString, and then we will later on use it constructing a longer version of conversion of our object to a string in this particular instance. So on the slide we say that in particular, to call a superclass constructor, of course you can use a super keyword, but this is also to call the superclass method. We do the same thing. We use the superclass keyword. By the way, in Java, just to clarify this for us, let's just go do another demonstration here. That if I have some kind of inheritance defined, so I have one class, I have another class, and I have another class, right? Perhaps what I decided to do is that I want to have a basic shape, right? Then maybe I decided to add a rectangle. And then I also want to add a square, which is a rectangle with all sides equal, right? So I could maybe, I'm just speculating this, maybe I could have an inheritance diagram like this, right? So if I have inheritance diagram like this, so this is the basic shape, this is rectangle, and this is the square. So if square implements a method here, right, implements certain method, or if rectangle here implements a certain method, in the square method right here, if I want to call a superclass implementation, I only have a super keyword, right? So I am not in control in terms of which method am I going to call. You see what I'm saying is that if a method is redefined in this class hierarchy, you know, and if I use super keyword to make a call to a method which is defined someplace in this hierarchy, it's the closest method that is going to be invoked. I don't have a way to say, no, call the earlier version of this method, which potentially could be defined here. No. In Java, you can only call the superclass, and that's the closest method to you that you can invoke through the superclass keyword, right? So the superclass keyword, when you call a method name, it is only limiting you to the implementation of the method which is nearest to you in this inheritance of different classes, right? So you don't have control to say call a rectangle method or call a shape method with this particular name. Superclass the super keyword will decide for you which one is going to be called. Unlike in C++, you can specify specific method of the specific class to which you can call. So you have a little bit more control. In Java, the communication from the subclass to superclass is only through the super keyword. You're limited to making this call. So in many instances in Java, it's easier for programmer to do things because there's typically a very specific and very direct way of doing things. In C++, oftentimes there are many ways to do the same thing, and that makes language a little bit more complicated, right? So just for the comparison.